It is believed that the ancient Egyptians used to drink water from the Nile River around 5,000 years ago. Turns out they're not really smart, because why shouldn't they use the water filter? It is believed that all organisms require water to live.
Yes, I acknowledge that all living things need water to survive.
So, could you say that fishes get thirsty in the sea?
But
Factories that mass produces water nowadays have machines that determine the time taken for each bottle being filled by water. The knowledge of differentiation of mathematics is applied so that the same amount of water is filled in different bottles. The idea here is that the height rate is used to calculate the time taken by the machine to fill each bottle. Yeah!
It's explanation time
with Professor Baim.
Alright, to find the rate of changes, first we need to sketch the diagram to represent the problem. As it's already sketched here, we can see all of the labels of variables that represent. Second, we need to state the variables involved, the value of h and r and t, which t is where we want to find. And third, we need to find the equations which related to those variables. Since the water bottles are similar to cylinder, we would use the cylinder's equation, which is v over equals to pi r square h. Fourth, we need to find the rate of changes of the variables. Here, we need to differentiate v to dv over dh. Before that, we need to ratio r to h to substitute r into h, and therefore we get only one variable in the v equation, which is h. After that, we can differentiate v respect to h. For dv over dt, there's already a video of how we want to calculate for 1000 centimeters cube to get the specific seconds for it to fill into that volume. So we got here the value of dv over dt is 34.48 centimeter cube per second. So on to the next step, we need to substitute the variable with the given rate, which we want to find dh over dt. By using the chain rule, we could multiply dh over dv with dv over dt. And 6, by solving the problem, we just simply substitute these values where dh over dv is opposite, is where dh over dv we need to change the position of the values, and we multiply it by dv over dt, and then we could get the value of dh over dt with respect to h. So here we want to find the water filled with 7 centimeters. So here we need to substitute the value of h with 7 centimeters. Then we would get the final value of dh over dt, which is 0.723 centimeters per second. So to find h, to find t, we need to So to find t, we need to ratio the 0.723 centimeters over 1 seconds to 7 centimeters over t seconds to find the value of t time taken for the water to fill into 7 centimeters. And then we get the value of t, which is 9.68 seconds. And that is the way how we want to find the value of